Hey guys, I I want to show you this is going to be a quick video about how to do this. Well, actually, let me run this. Right, so I've got a few questions about how I did this. You might see a few bugs, a few issues with. So essentially, as you rotate around the character, this is a very it's a classic effect in video games, right? Where as you rotate around a character, he changes the direction of movement, right? Because he's actually facing forward. He's actually facing this direction, right? And yeah, I think it's called an eight directional billboard. So what's happening here is I'm missing the frames in this animation because I haven't finished the whole thing. Anyways, I'm going to show you a quick video. I'm going to show you because I've got a lot of questions about how to do this in Godot, right? And to be honest, I haven't seen. Anyways, let me quit this. So I haven't seen many tutorials, but then again, maybe I didn't look that hard. You know, I was just trying to figure out. I was trying to figure out even how this thing is called, right? Like how this eight-directional movement is called. I'm not sure. So let's just call it eight-directional billboard movement, right? So what I did here, okay. Let's see. So I made the walking animation. Right now I don't have any AI on my character, so they're just playing an animation, right? So I made the walking play by default, right? So I tick that one, play by default, right? So and then let's play it. So let's see how it looks like, right? So as you can see in here, you won't change anything, right? And it's only one animation. Normally I would have to make different animations for different directions, right? But this is all done in script. So this is the character. So if I go to script now, okay, well, first of all, let's see here, right? So what do I have here? I have a script which is called human, right? So this is all the human script, right? And if you look here, it extends creature, right? I'm just explaining my project too, so it makes sense a little bit, right? So it extends creature. So creature is like a generic script that all creatures will have, right? So it makes life easy. So I have all my data here, and I have a couple of like utility, variables, variants. But the whole magic happens actually right here. Right, it's right here. So from here all the way to here. So this is what we're going to focus on. So first of all, I have a, I guess I have to include this one too, right? So first of all, we have a variable called far, right? And a variable called far represents if a character is too far away from the player, right? I don't know if this is the best way of doing it, but I'll show you my way of doing it. So what I do is I get the global, as you can see, like this one extends kinematic body, right? And if I go back to human, right? If I go back to human over here, right? This is a kinematic body, right? And the script extends creature, and creature extends kinematic, right? So essentially, this script will extend this script, and it would let's say shape this script into whatever I want to make. So if I want to make a spider, I will have a spider GD with spider properties that extends creature. If I want to have a, so forth, right? So that's kind of why I did it this way. I mean, maybe it's not the best way, but this is what I've done, right? Anyways, and let's see. I don't want to make it this too long. I want to make sure that you guys have enough time. 4 minutes. Okay, that's fine. Right. So let's go back to what I have here. So I have data is like all the creature data, right? I could actually make a variable out here, but usually I put the utility variables here. Any variable that I want to reuse is going to be inside data, right? Because why? Because this is a dictionary. It's a dictionary, right? So I can keep adding variables in here. So it helps me in the future. I will keep adding new variables in here, and it will still be backwards compatible, forwards compatible, and so forth, right? That's kind of I want to make sure that I keep anything that pertains to the character inside the dictionary rather than right in here. Anyways, so let's go back. So I keep it in data. Most of the stuff you'll see is in data. So I have a variable called far, and what I do is I get the global transform origin of what? Of the kinematic body, of the object itself, right? Essentially, this is the same as self, right? If you don't call self, then it becomes, it's automatically added to whatever you're calling, right? So I'm getting the global transform, the origin, right? So I'm getting essentially the global x, y, z position. And then from that position, I want to find the distance to what? To player, right? My player character, I don't want to go into this, but essentially my player character is always saved in a globals variable, so I can quickly access him from anywhere, right? There's certain variables that get accessed, like player is a very common character that you want to access from every function, right? Because he's like kind of the target, right? Usually if you meet someone, if you attack someone, then you can quickly get the attacking target when you touch him, right? But some things you want to get him all the time, like player, right? So it's saved in a player. So essentially, like what am I doing here? I'm getting the distance to player, right? I'm getting the distance between this creature and the player, right? And if it's less than player sight. What is player sight? Well, it's sort of hard to see here, but essentially all my characters have senses. So my character has a sight. It's actually not 1. It's actually 10. So if it's less than 10, right? Because this is the default. This is everything is defaulted to 1. But then each individual script for each individual creature will like change that, right? So it's 10, right? Because why is 10? Because my character is also a human. I don't want to go into that, but essentially my character is also a human, right? So it would have a human characteristics, right? So if the distance between this object, this creature, and the player is less than the player's sight, okay, and the far is false. So if it's not far, then you set it to true. You set the far to true. Else, you set the far to false, right? Else, if far is true, set it to false. Essentially, what I'm saying is, if the character is within, if another character is within the player's sight, okay, then make sure the far is set to false, right? Otherwise, set far to true. Right. Essentially, it's actually backwards. It resets it. That's what it is. If far is not, if your character is within the player's sight and far is not true, set it to true, right? And if if far is not, I'm getting myself confused now. If far is not false, set it to false, right? If otherwise right? If otherwise the player is outside the sight range, then if the far is true, set it to false. Because if this will not be true, then this will always be false. So then this one just resets it, right? So essentially what I'm trying to say is, whenever player is within sight range, set far to false. If player is outside of far range, like sight range, set far to true, right? And this is very relevant. This is very important because I only process the billboard stuff when far is false, right? So when the character is within sight range, right? So I don't want to process billboard on all characters all over the map, right? I want to do it only on the characters that are visible, because it's kind of irrelevant, right? The game engine deals with the actually visually displaying things, because everything is frustum called, I think, automatically. But the scripts are not. Scripts will always run. So I have to give them some parameters, like don't only run the script as long as the character is not too far. Okay. Sorry, anyways, and so I think that we figured that out. This one is whenever. So what happens is the way my game works is that I have a player controller node. I should show this actually. There's a PC control node right here, right? And the PC control node is added on top of a human, right? and the PC control node will modify the human character from an AI character into a player character, right? So the way it does that is it does all these different tricks, right? It sets all these different things. I have a thing called, I don't want to go into too much stuff, but essentially it will set a variable PC is equal to true, right? So that means that this human character is a player controlled character, right? So it will have a special privilege. It will work differently than most characters because it's controlled manually by a player, right? So essentially, what I'm saying here, if this creature, right, is within the sight range of the player, okay, and if it's not the player, because I don't want to process billboard on itself, right? Because you will look at yourself and it will fail and it will keep crashing and doing weird stuff. So okay, then this is the magic. This is where all the magic happens, right? I do the sprite, okay, and if I go up here, you will see that the sprite is essentially the sprite node. Like this is same as get sprite, and in Godot 3 this is same as get node sprite, right? And if I go here, is essentially I'm getting this node right here, right? So let's go back. Okay, so I'm getting the sprite, right? So I'm getting the sprite node, not the whole kinematic body, but only the sprite node, right? And then I'm making it look at the player X, sprite Y, and I'll explain to you in a moment why I do that, and player Z, right? So what do I do that? I look at the player X and Z, but the sprite Y. So I want to make it Y billboard. I don't want to make it do this. So the sprite always looks the same height. It will look at the player, but if the player is here, it will stay like this. If I use the player's Y, then it will do this. It will also do this. I want it to stay straight, right? So this is essentially what I'm doing here is a billboard Y. I'm not using the billboard built-in function from what's it called, Surface, right? Because I don't have control over it. Like that billboard function not exposed to script, so I don't know what direction it's facing. I don't know anything. It's all done by, it would be more efficient visually, but I don't have control over it, so I won't be able to tell direction that the sprite is facing, right? Which is very important for me. Like I also need the direction that the sprite has rotated, right? And here is just this globals is just a vector. It's just a vector. It's essentially it's just a vector that shows the up direction, which is the Y is the up direction, right? Like if I go globals, somewhere here, up, yeah, there you go. See? It's X, Y is up, so yeah, it's very simple. That's how the lookout in the Godot 3 requires you to have a up direction now. I'm not sure if that was all the time. And then I flip it. For some reason, it's making the back of the sprite look at the character. I don't know why it does that. It's weird. It doesn't. It does. So this is the sprite forward for me, but it uses this side to look at. So this is the sprite forward. But in the editor, this is the sprite forward. But in the look at, this is the sprite forward. Whatever. Let's just let that slide, and I'll just use whatever it has. Okay. So I'm just flipping it. Essentially, I'm just flipping the rotation degrees. Right? I like to work in degrees. I don't like to work on radians and all that magic stuff. Right? So essentially, I flip the rotation degrees to 180. So it's not the back, but the front that is looking. Without this, we'll just show nothing because the back is cold. So it shows me the back, which is being cold. So you don't see anything, right? Right. So what have I done so far? Right. I'm making sure that the character is visible, right? And the character is not the player, right? And then if that's true, then I make the sprite look at the player, right? And then I make the sprite flip 180, right? So this is the magic now. This is where the magic actually comes in. There's many ways of doing this, right? But the way I've done it is I essentially I get the sprite rotation Y about its axis, right? That's the rotation Y. This is rotation Y. I'm not sure exactly. I think that I'm not sure the terminology. Pitch, yaw, or something. Anyways, it's rotation about its axis is Y, right? So I'm getting rotation about its axis and divided by 45. Why? Because 360 divided by 45 is 8. and I need 8 directional frames, right? It's north, south, east, west, northeast, northwest, and so forth, right? So I go like tuk, 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 tuk. So it essentially switches every 45 degrees, right? So this is what there could be other ways of doing this, to be honest. Like now that I'm thinking about it, like I could actually stepify the rotation degrees y and then divide by 45, right? So I wouldn't have to round, and I could do that too. I stepify. I don't know. But what happens is, here's the interesting thing, right? What happens is that you have two cases where it's the same thing but two different values. You have 360 divided by 360, 0. So you have, for example, 0 divided by 45 is 0, right? So that's the first frame, right? 360 divided by 45 is 8, right? But those are actually the same value. Those are forward, right? Because what's happening is you go from 0 to 360, but 360 and 0 is the same, right? So what's happening is that I actually get 9 values from 0 to 8. It's 9. 0, 1, 2, 3, you know? So I get nine conditions, right? So it should be from 0 to 7 or from 1 to 8 to be 8 positions, right? So this is why I do this, right? I say if the sprite is 8, then just make it 0. You know, make sure that the last frame is actually 0. So you go back to the beginning, right? Like go back to the 0. Because otherwise I would have 9 positions, right? And here's where the magic happens, right? This is what I chose to use animation. So if you look in here, actually I started with this. I have an animation player. And the animation player, if you actually go right here, the animation player is, let's see. Yeah, like right here, there's the animation player. And then the animation player has two keyframes, right? And let's see. So it has 2 keyframes. What is the first keyframe? 0, and the last keyframe is 3, right? You gotta remember it starts from 0 to 3, so it has 4 frames. 4 frames. 0, 1, 2, 3, right? 0, 1, 2, 3, right? 4 frames, right? So essentially, I do a clamp interpolation and linear, continuous. So it will just go. What it will do is go 1, 2, 3, 4. It will try to figure out what the right frame are in a linear interpolation, right? So it's automatic. I don't have to do frame 1, frame 2, frame 3, frame 4. It's kind of cool. This is why I do this, right? Because otherwise it would be more code, right? Right. So that was the walking animation, right? But then what I do is I get a sprite frame, which I get it right here, right? I get the sprite frame, so direction that is facing. If it's facing one direction, so for example, if the direction that the sprite is facing is 0, right? 0 divided by 45 will be 0, right? So the sprite frame will be 0. Sprite frame will be 1, 2, 3, 4, 5. It has a certain order that it goes, which is counterclockwise, I think. I think it's counterclockwise, yeah. Right, and so this is you get it right here. And then you multiply that times 4. Y times 4. Because you're trying to get the next frame, the next walking frame, right? So now I have to go over here so I can explain to you what's going on. So 1, 2, 3, 4 for forward. This is why it was showing blinking, because I'm missing these frames. But essentially 1, 2, 3, 4 for sideways. 1, 2, 3, 4, right? So I multiply by 4. If you're in direction, if you're sprite frame or direction 0, then you want to get the first 4. Then you want to get the next 4, and then next 4 after that, right? So if I go back to Godot, then this is exactly what I'm doing, right? 4 plus, I'm getting the sprite frame plus 4, so direction 0 is 4. Next direction is going to be whatever, 8. Sorry, first is going to be 0, then 4, then 8, then, I'm getting every 4, right? Okay, and yeah. Anyways, and that's kind of the idea, right? And so what I'm doing here, okay, is if the animation is playing, and the current, then get the current animation, and the current animation is walking, for example, right? Then modify the keyframes, and this is the trick, right? This is the magic trick. Magic trick is that I'm modifying the keyframes. So I'm essentially modifying these values right here, right? I'm modifying these values. So if I can actually do this right here, if I go from, for example, 4 to 7. See, it's doing this the side. Now it's doing the side one, right? The one that was missing, right? 0 to 3, right? Okay, there you go. So I'm modifying these keyframes for the walk animation. See, for the walk animation, I'm modifying these keyframes to match the direction. Okay, how long? 20 minutes. Okay, I gotta cut this short because I've been talking for so long. But I hope that this helps, right? Essentially, this is what I'm doing. Say +3, right? Why? Because it goes from 0 to 3, right? So I want to make sure that those two keyframes, they skip to the appropriate direction. And then the appropriate direction is what I call sprite frame, which I get it right here. Okay? So the effect is this. Right? The effect, I guess I showed you already, but if the effect is this, right? The effect is that it will, see, it's getting the direction, and now it's facing 0 or 360 forward, right? Well, actually 0 or 360 is more like here, but, right? It's getting sideways, right? It's getting this way. You see? So the direction got skipped. So those 2 points got skipped over 1, 2. Right? All the way to where was my image? So it got skipped over this, all the way to here. Right? So that's why it does the times 4. So the direction is 0, direction is 0, the direction is 1, the direction is 2 times 4. Right? So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so forth, right? I hope you understand, like that 10, 11, blah blah. So that's exactly how this code works, and you know. So it gives me this gives me control over the frames that I want to play from different directions. All I gotta do is add this data times sprite frame times the amount of frames, right? Times the amount of frames, right? And that modifies it. See, like for example, right here, the idle animation is different. The idle animation actually uses a mix of first frame and a special frame, which will be over here. So it does this. It looks forward, left, right, forward, left, right. Okay. So I take an animation. I take a keyframe from here. 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 Right. So this is why it looks like more like strange. It actually makes sense if you actually look in the. Let's see. I know. See. I take a keyframe 33. I take keyframe 32. I take keyframe 34. I take keyframe 32. Right. And it gives me. Let's see. What is it? Gives me this. Yeah, this is wrong actually. This is actually wrong. But the thing is, the script fixes this, right? It should actually be. It used to be different before. It should actually be. I take keyframe. So whenever, it should be keyframe 0 here, I think, and then it should be 0. Yeah, and then here is gonna be 33, and 30, no, here should be 30, 32, 30. Yeah, there you go. See? I hate these gizmos, man. There you go. See? It used to be different. I used to have the frames 1, 2, 3, 1, 2, 3, but then I realized, well, what's the point of doing that? I can just steal the frame from here because it's the same. So I for forward, left, forward, right. You know, forward, left, forward, right. So this would work actually the same way. Right. So let me see if I can play this, and let me see if this should actually do it properly. It should look left and right. Let's see if this works. Yeah. See? As you can see now he's moving the idle, but the idle is based on direction. He's looking left. The animation is not perfect. There's still problems with it. It actually takes a long time to create this kind of animation. But anyways, I hope that helps. I hope that helps with figuring out this billboard movement. I want to show you one more thing actually. So if you see here, the all sprite frame not equal to sprite frame, all sprite frame not equal to sprite frame. You see this thing here? So I skipped over this, but essentially this code only works when the sprite frame changes. So when I change the direction. So if my character moves to a different direction, then it will play that. Then it will run this code, but only once, right? So it only makes all these changes once, right? This is the way. It's an optimization. Essentially, like by adding this code, I make sure that I don't run this code like a million times per frames, like 60 times per frame or whatever. My game is 30 frames per second, right? I don't want to run this code 30 frames per second. I only want to run it once because it only makes changes once per direction, right? So this is why this is an optimization. You don't have to do this, but this helps. And to prove that, I want to show you something. To prove that, I'm going to go in my game. This is my character. See the direction he's facing this way. I want to make him face a different direction. Let's see what happens. I want to show you that it actually works. Like, so my character is going to point. Obviously, the back is cold, but my character is going to face backwards from me, right? Okay. So now, if I'm running the game, when I look at him, I should see the back, right? And then let's see that happens. See, works. You see? So his front, it was in this direction, which is correct, right? And that works. That works because it's actually very interesting. It's actually a shortcut, and I can explain that to you really fast before I run out of time. That works. Why? Because the look at. So inside the creature, I have a look at. This look at happens in global space, right? Okay. However, the sprite rotation degrees happen in local space, right? So I'm moving the sprite according to the global location of my character. So my sprite, the sprite faces the global direction of my character. However, I'm getting the local changes, right? So I'm only figuring out the sprite rotation locally. So that means that I can rotate my character, and my character will still get the appropriate directions, right? If I would have done this in global space, then he would always change the frame location in the same location, right? But anyways, I hope that helps with it's not the best way of doing it, but it's the only way I figure out how to do it, and it works quite well actually. It surprisingly works quite well, and you can do a lot of powerful stuff. Like you have the power to change frames on the fly. I keep sliding in frames whenever I want to, or whatever conditions I have to. Being able to expose that rotation of the billboard to the script gives me a lot of power, right? That's why I opted to not use the surface, the visual, whatever, and then just because you had to you had to calculate that direction anyway. So the engine doesn't have a built-in way to do that, as far as I know. So, anyways, that's all I wanted to say, and hope that helps for you guys.